Hello. In this safety briefing, we'll be covering milling machines. And a milling machine is a device that's designed to remove material from the surface of a part, usually a metal workpiece. For example, this piece of aluminum right here started life as a larger block, and we could use a milling machine to make a very precise flat surface right here. We could do that on the sides to bring them to an exact length. You can see that there's a couple of grooves that have been cut into the part as well. And then many milling machines are also designed to be able to drill holes, and so you can see a very precise pattern of holes of two different sizes that have also been put into this part. And a milling machine can do that very accurately and very powerfully. The first machine that we're going to be looking at is a horizontal milling machine, or horizontal mill. And it's called that because the business end of the machine, the part that actually does the cutting, so our cutter and our spindle, are designed to spin on a horizontal axis across the surface of the part right there. The other type we'll be looking at a little bit later on is called a vertical mill. Before we dive in, I just want to remind you that the standard safety procedures for any machine tool apply. So safety glasses, bare hands below the elbow. You can see that I'm keeping my silicone ring on here, which is designed to break. Other than that, long hair pulled back, being aware of anything on your body that may get caught in the machine. The other additional feature of a lot of metalworking machine tools is that because of the forces involved, we are not going to use our hands to guide the work through the machine. Instead, what you'll see is it mounted very securely to the machine. And in this case, what we have is we have a vise that's mounted directly to the table. And what we're going to do is we're going to take our workpiece, in this case another block of aluminum, and we're going to clamp that tightly in the vise. In fact, on this particular type of vise, I can even take the handle off so that it doesn't get in the way as I work with the rest of the operations that I need to do. Of course, that means then if I am going to have my part securely clamped, either in the vise or sometimes even clamped directly to the table, I'm going to need a way to be able to move that part or move the cutter so that I can accurately do what I want to do, because I'm not using my hands. And to do that, we have three controls that control the direction of the table right here. The first one, you can see in my hand right here, is a dial that will move the machine in this direction. The second one is a dial that will move the machine forwards and backwards. And then the third one is a dial that will move the entire table up and down like this. And although it's probably hard to see, each of those dials is graduated in very small tick marks on the dial. So when I move it, I can move it accurately. And this machine is divided so that each tick mark there is 1/1000th of an inch, 0.001. And those are available on all three of these. Yes. So then, the process of milling, the most basic operation that we're going to look at, is going to be using a cutting tool to go across the surface of our part to make that surface very nice and flat and smooth, and will remove an exact amount of material off the top. The cutter that we're going to be using to do that on the horizontal mill is a fairly large one. It looks like this. And if you can imagine a saw blade, so you can kind of imagine the teeth that you might have on a saw blade, but then you take that saw blade and instead of being just a skinny disc, we stretch it out wider so that it becomes an entire flat surface like this. It has very sharp teeth, and as this cutter rotates around, those teeth will be shaving away material from the surface of the part. Not all cutters look like that. We can get a cutter, for example, that's much more narrow, like this. So we could shave off a small surface or even cut a groove into that surface. And this cutter has pointed tooth on, so we could cut a V-shaped notch, or we could put an angle on the side of a part. And there's other shapes that are possible too. But we'll be using this one right here. Now, just like a saw blade, just like really any other cutting tool that we've learned about, the teeth are designed to cut in one particular direction. So if you look closely at those teeth, you'll see that they are hooked in one direction, and that they have relief, or they curve backwards in the other direction. And so we need to make sure that we rotate this in the right direction. And the correct direction would be like this, so that the angle of the teeth go into our material and they shave away the material as opposed to just rubbing against it. The other thing that's important is as we do that, as we rotate it like that, that our material rotates in the opposite or moves in the opposite direction. So if our cutter is going to be rotating in this direction, our material is going to be moving against it in this direction. So the two are going in opposite directions like this. Now again, this might be a little bit hard to see on the video, but if you look at the cutter in the spindle right there, if I rotate it this direction right here, you can see that those teeth are actually going backwards. They're not going the correct direction. If I rotate it in this direction, then those teeth are going to be coming around like this and are going to be shaving the material. So again, maybe hard to see in the video, but if they come around like this, and the bottom is going like this, that means our work underneath needs to feed in the opposite direction. It needs to feed in this direction. So I'm going to start with my work over here, and I'm going to feed it over in that direction. So the initial process that you'll see me do, and I'll do this standing on the other side of the machine, is to bring my piece gently underneath, touch the cutter to the surface of the part, and then move out of the way, and then that'll find the upper location. That'll find the upper surface of that part. And then raise my table so that I can get an appreciable cut on there and start cutting across the surface. And so we're going to zoom in on this just a little bit so you can see how that works, but still see the controls of the machine. Okay, so I'm going to start this spinning. And I'm raising the cutter up until I'm just touching the surface of the part like that. You move it out of the way. And at this point, I'm at the level of the part. The cutter is just basically scratching the surface, and so in the vertical direction, I'm going to set the dial here to read Z equals 0 down here on the vertical dial. Now what I'm going to do, I'm going to back up a little bit more, and I'm going to take 20 thousandths of an inch, 0.02 off the surface of the part. That's a fairly light cut. I'll move somewhat slow on this. But even though it's a light cut, and this cutter is very sharp and the machine is very powerful, we're going to create a lot of friction in there. So the other thing that I'm going to do is I'm going to take a little bit of cutting oil, I'm going to put that on the surface of the part right here. And that'll help reduce the friction and cool the tool as we make this cut. And I want to emphasize that I'm doing this with the machine off. The great thing about metalworking machines as far as safety goes, they have very many things to be careful of, but all the controls are located far away from where the actual sharp, powerful cutting stuff is. So my hands, when I'm working on the machine, are a safe distance away, and if I need to work up in this area, I'm going to turn the machine off completely before I do anything in that area up here. So now I'm going to turn the machine back on, stand over here, and make this cut. Turn the machine off. And we'll remove our piece from the milling machine. And so you can see here what we've done is we've taken this surface right here and made that flat and smooth, and we've taken exactly 0.020, 20 thousandths of an inch off the surface right here. Now that may not seem very exciting. That's the foundation of milling, is to mill a flat surface like that. And like you saw, we could have other cutters that we could replace on our spindle in here to do different things. But I will tell you that a horizontal mill excels in doing that right there. It excels in making flat surfaces on a part very accurately. And what we'll do in just a bit is we'll look at the vertical mill, and we'll see how really that has a lot more versatility, a lot more different types of cuts that are easily done on a vertical mill.